Explaining our research on the investigation of coefficient of thermal expansion of different metals. I'm Glenn Liu and my teammates are Ashton Lim and Destin Tan. When matter is heated, it expands. This is known as thermal expansion. Our research question is to investigate the coefficient of thermal expansion of different metal bars. Why? In aerospace and electronics, when we understand the values of thermal expansion of different metals, we can ensure that the materials used can withstand temperature fluctuations. This allows us to improve the longevity and the structural integrity of the products. This also improves overall safety. Renewable energy technologies, such as turbines, solar panels, etc., must withstand high temperature changes. More knowledge on thermal expansion allows us to lower the maintenance costs and encourage more sustainable technologies to be built. Finally, it allows us to create more alloys like high entropy alloys, the copper nickel silicon alloy, the RMEA alloy. These alloys are more efficient, durable, and environmentally friendly, allowing innovative engineering solutions. We hypothesized that aluminum would expand the most, while carbon fiber would expand the least. Here are the rest of the results we hypothesized after our research. In order from least thermal expansion to most, we have carbon fiber, iron, steel, copper, brass, and aluminum.
This is how we did it. Since thermal expansion is subtle, we had to use a special setup. First, we will shine a laser using a laser pointer towards the screen. Two laser blades, one attached to the metal bar of choice in the hot plate underneath, will be positioned in front of the laser. The laser blades will be set up so they are barely touching one another, not enough to block a laser, but enough for diffraction. When the experiment starts, the hot plate will heat up the bar, which expands and moves the laser closer to the other one. Here are some photos of our setup. At the start of the experiment, the screen will have the diffracted laser projected on it like such, with the laser dots being shorter and closer together. This is because the light spreads out more on a wider slit. At the end of the experiment, the laser dots will be wider and closer, as the light has spread out less due to the slit size decreasing. Here are some photos of our experiment results, the top one being before and the bottom one being after. After some math to calculate thermal expansion by afterwards, here is our data. For comparison, here is the two graphs plotted side by side.
Our results concluded that copper expanded the most, while steel expanded the least. According to our graph, our results were incorrect. However, the trend of difference in thermal expansion was similar to our hypothetical results, the only exception being aluminum and brass. To understand why steel expanded the least, we have to look at the atoms of the structure of steel. The crystalline structure of steel is a body-centered cubic structure. This means that unit cells have 8 corner atoms and 1 dead center. Although this gives the atoms more space to move, they are packed less flexibly. On the other hand, bronze has a face-centered cubic. This means that it has 8 atoms in the corner, but 6 atoms for each face of the unit cell. This arrangement allows for both flexibility and a nice arrangement to move around. This brings us to our further areas of research, where the independent variable could be changed to the alloy ratio and the different types of materials like the different types of carbon. Thank you for listening.